This lesson is over finding domains of functions. Finding domains of functions means the domain is the set of all input values that result in a real number. Do you remember what real numbers are? Well, recall, real numbers can be positive numbers, negative numbers, big values, small values, fractions, decimals, and everything in between. Now, when the result is not a real number, we say the function value does not exist, or DNE, and is therefore not part of the domain. Now, we assume the domain is going to be all real numbers, unless the function is made up of the following. If we encounter rational functions, do you remember what rational functions are? Rational functions are basically fractions that have a variable in the denominator. Second topic is radical functions. Radical functions, specifically with radicals that have an even index. Now remember, an index is the little number that lives there right beside the radical. These are the only two key issues to be on the lookout for: fractions and radicals. Rational functions with a variable in the denominator. Well, we know that fractions cannot have a denominator equal to 0. Therefore, we must find any values that cause the denominator to equal 0 and remove them from the domain. But how do we do that? Well, the approach is to take the denominator and say it cannot equal 0. So let's look at an example. Example 1 says state the domain in interval and set notation. For a, we have the function g of x equals 1 all over x plus 2. Notice there's a variable in the denominator. So how do we go about finding the domain? Well, remember, it says to take the denominator and say it cannot equal 0. In this case, our denominator is x plus 2. So we say x plus 2 cannot equal 0. Now we want to solve for x and try to get x all by itself, which means we need to subtract 2 on both sides. In doing so, we find x cannot equal -2. Now, what does that really mean? Well, let's look at the number line. What that means is on the number line, I cannot include -2, which means I put an open circle around -2. In other words, I can use all the numbers on the number line. I can use any number to the left of -2, and I can use any number to the right of -2. -2 is the only number that we cannot use, and we are removing it from the domain. But how do you write this as a domain in interval and set notation? Well, let's look. We were just looking at the following. Now, to write this in interval notation, we look at the number line. Interval notation is where we look at the number line from left to right using the grouping symbols parentheses and brackets. So we start on the leftmost side and we find what's the furthest left we can ever go on the number line, and that's -infinity. Now we must decide, do we use a bracket or parenthesis? Well, bracket means equal to or includes. Parenthesis means does not equal or is not equal to. Well, since nobody knows where -infinity ends, we cannot confidently use a bracket. So we must use a parenthesis. And as we follow the number line to the right, it is colored all the way until what number? -2. Now, do we include -2? No, that's where there is a hole, which means we cannot use a bracket. Instead, we must use a parenthesis. Now because we have this hole, we have to use the proper symbol known as a union. It means there is a jump in our coloring, or there is a gap in our shading. It means or. And we pick back up on the other side of -2. But again, I cannot include -2, so I must use a parenthesis. And I continue shading to the right on my number line all the way until infinity. And whenever you have infinity, you must always use parentheses. So that is your interval notation. Now we need to write our set notation. Set notation is the more formal way to write your solution, and it would look something like this. Now, let's be honest. How do you say that? Well, in math, each symbol has its own meaning. So the way we read this is the following. The brace, or the squirrelies, means the set of all x values. Now that straight bar means such that, and then we read x cannot equal -2. Example B. We have the function h of x equals 1 all over x minus 4 times x plus 5. Notice there is a variable in the denominator, so we need to investigate the domain further. Now remember, the approach is to take whatever the denominator is and say it cannot equal 0. Well, in this case, our denominator is x minus 4 times x plus 5. Now x minus 4 represents some number, and x plus 5 represents some number. And so what we have is some number times some number equaling 0, and we can't let that happen. But the only way two numbers can multiply to give you 0 is if one of the numbers is really 0 in disguise. So we need to investigate both values. The first number, x minus 4, we say x minus 4 cannot equal 0. And now we need to solve for x. In other words, to get x by itself, we need to add 4 to both sides, and we find x cannot equal a positive 4. Now we need to investigate the second value, which was x plus 5 cannot equal 0. And to solve for x, we must subtract 5 on both sides, and we find x cannot equal -5. So we've identified the two values that cannot remain in the domain. So let's look at the number line. We said x cannot equal 4, which means we have an open circle at 4, and x cannot equal -5. So we have an open circle at -5. As long as x is neither of those numbers, we are okay. So means I can shade all the values to the left of -5. I can shade all the numbers between -5 and 4. And I can shade all the values to the right of 4. Every other number can be included in my domain. So how do we write this in interval notation? Well, remember, we read the number line from left to right. The furthest left on the number line that is shaded would be -infinity, where we always use a parenthesis. Now as we follow to the right along the number line, we shade all the way until we reach the number -5. But we do not include -5, which means we use a parenthesis. We have to jump over -5, which means we use the union. We continue and we pick back up on the other side of -5, where again we must use a parenthesis because it's not included, and we shade to the right all the way until a value of 4. Now at 4, notice there's an open circle, which means we cannot include 4, so we must use another parenthesis. We must get on the other side of the open circle, so we have to use the union. And now we're ready to shade to the right of 4, which goes all the way until infinity, where we always use a parenthesis. So that would be your interval notation. Now for set notation, remember this is the formal way to write this. It would be the set of all x values such that x could not equal -5 and x cannot equal 4. Example C, we have f of x equals x plus 2 all over 7. Notice there is no variable in the denominator. So what does that mean? It means there's nothing to be concerned about. So look at the number line. If I have no concerns, that means I have no open circles. So the whole entire number line would be included. So interval notation, which we look to the left, would be -infinity with a parenthesis, and we shade all the way to the right until positive infinity, where again we always use a parenthesis. There is no problem numbers. Any number you can dream up will work. Now for set notation, that would be of the form the set of all x values such that x is all real numbers. Now let's talk about when you have a radical with an even index. Let's refresh our memory about radicals. So let's look at the following. Say you have a square root of a positive number. Well, think about it this way. Can you take the square root of 25? Yes. How about the square root of 9? Of course. How about the square root of 4? Yes. Now notice 25, 9, and 4 are all positive values, which means it is possible to take the square root of a positive number. So we're okay with that. Now let's look at another possibility. Can you take the square root of 0? Well, what is 0 times 0? 0. Therefore, 0 does have a square root, so that is okay. Let's look at another option. What about the square root of a negative number? Can you find the square root of -49? Well, keep in mind a square root means some number times itself has to give you -49. Is that possible? Well, what about the square root of -16? Is that possible? Well, maybe the square root of -4? No, it turns out that is not possible. It's not a real value. Any number times itself cannot produce a negative number. So, in other words, the number under the radical must be positive or 0. It cannot be negative. So how do we go about finding the domain when a radical is involved? Well, your approach is to set the radicand greater than or equal to 0. And as a reminder, radicand simply means the number under the radical. Example 2 says, state the domain in interval and set notation. For A, we have g of x equals the square root of 2x minus 8. Notice that we do have a radical with an even index. We know that because we read that as square root, and square implies there's an imaginary 2, which of course is an even number. Alright, so let's refresh our memory about this. We just said that the approach would be to set the radicand greater than or equal to 0. In this case, our radicand is 2x minus 8. Now we need to solve for x. We would need to add 8 on both the left and the right side of the inequality. which gives us 2x is greater than or equal to positive 8. Now to get x by itself, we must divide the left side and the right side by 2, which leaves us with x is greater than or equal to 4. So now, what does this really look like? Well, let's look at the number line. X is greater than or equal to 4. In other words, something important is happening at 4. Now, from here, we have to decide half the number line is going to be a true statement. What half represents the values greater than 4? Is that to the left or to the right? Well, greater values mean bigger values, which means we would shade to the right on the number line. Now, it says x is greater than or equal to, which means can we include 4? Yes. Now remember, the symbol of a bracket is used when we include a particular value. So we will include a bracket on the number line. So now that we see the shaded region, we're now ready to write our interval notation. Our shading starts at the value of 4, where we do use a bracket. And we shade to the right for forever and ever, which would mean infinity, where we always use a parenthesis. So that would be your interval notation. Now again, set notation is the more formal way to write this, which would simply be the set of all x values such that x is greater than or equal to 4. Example B, g of x equals the square root of 2 minus x plus 5. Now notice, we do have a radical with an even index. So here's a reminder of our approach. We take the radicand. Now in this case, what is the radicand? The radicand is simply the 2 minus x, and we set that greater than or equal to 0. Now we need to get x by itself, so we need to get rid of the 2, and to do that we would simply subtract 2 on both sides of the inequality, leaving us with not x, but negative x is greater than or equal to negative 2. To help isolate x, we need to divide the left side and the right side by negative 1. But remember, when you multiply or divide by a negative value, you must flip the inequality sign, which means you are left with x is less than or equal to 2. Since x is by itself, we have found our domain, but we probably want to draw the number line so we have a better understanding. Again, it says x is less than or equal to 2, which means something important happens at 2. Now, what values are considered less than 2? Are they the values to the left or the right? Well, less than would be to the left. So we shade to the left of 2. Now, it said x is less than or equal to 2. Because it says equal to, that means we will use a bracket and it will face the direction that you are shading. So now that we see the number line, we're now ready to write our interval notation. We read the graph from left to right. The furthest left we see is an arrow, which indicates negative infinity, where we always use a parenthesis, and we shade to the right until we reach the value of 2, where we have a bracket, because 2 is included as part of the domain. Now for the set notation, that would be the set of all x values such that x is less than or equal to 2. Problem C. h of x equals the cube root of 3x minus 5. Notice the radical with an odd index. Well, what does that mean? Well, it means we have nothing to be concerned about. So we look at the number line. Because this is an odd index and we have no concerns, that means the entire number line can be used and will be shaded. So your interval notation would go from left, which is negative infinity, all the way to the right, which is positive infinity. And so your interval notation is simply all real numbers. The set notation, again, would be the set of all x values such that x is all real numbers.